On to our next section. We're going to look if I can show that two triangles are similar. Now, the word similar is not just means like kind of the same-ish, like, oh yeah, they look alike, sort of. Similar is actually a technical term. It means something specific. And what it means is that everything about it is proportional. And the way I always like to think of it is if I took a picture of myself and I were to take that picture now and blow it up to make it bigger or smaller, would I look proportional or would I look kind of stretched out? Like if I scale this here, you'll notice that everything is still in proportion. Even if you turn it whatever, as long as things are proportional, you're good. It's not the funhouse mirror where you sometimes have part of it stretched out. So if I were to do something with this and it were to look like this, that would not be proportional. So that would be something different. So to be similar, it can be different sizes, but it still needs to have the same ratios of the sides. Still needs to be in proportion. So let's try an example. This first one here, we have a whole bunch of sides. And what I like to do is find the largest side and match it up with the largest side. Smallest side with the smallest side. Now here these are the same. And a medium one with a medium one. Now since the small and medium are the same on this one, I just kind of picked one. To me that's actually a red flag that it's not going to work, so I kind of know that already. But let's just go through the process just so you see it once. I always like to pick a common order and I want to write it down. So in this case I'm going to do the top over the bottom as my fraction. Top over bottom. It doesn't matter what you choose, left over right, top over bottom, whatever. It matters that you do them all the same. I like to do them this way. You pick yours. The top in this case is the number 25 for the red fraction for the biggest one, and the number 6 for the bottom triangle. And I want to see if that's equal to, switch my colors here, the 15 and the 2. I did the top one over the bottom one again. And I want to see if that's equal to the 15 over the 3. If all three of these fractions are actually equal to each other, then I have two triangles that are similar. If I don't have that, then they are not similar. And my big red flag is I see this here. 15 over 2 is equal to 15 over 3. And I know that that is just not true. Fail. So they are not similar. So we're moving on to the next one. On this one here, we'll take our longest sides and circle those, and our shortest sides, circle those. So I'll start with the shortest ones. Take my medium sides and my longest sides. I highly recommend using colors for this. It just makes life a lot easier. And I'm going to do top over bottom again just because. And that is going to be 4 over 8. And then I have this side here, and I'm going to do 3 over 6. And then I'm going to do my last one, and that's going to be 2 over 4. If all three of those are equally to each other, we are good. And if I now look at this fraction, 4 over 8, I know that reduces to 1/2. If you didn't know that, you could just pop in your calculator and do 4 divided by 8 and see what you get. 0.5. 3 divided by 6, 0.5. 2 divided by 4, 0.5. So if you don't feel real comfortable with fractions, just divide them in your calculator and write down the decimal underneath them all. Otherwise, if you're like, hey, I know that's 1/2, I know that's 1/2, I know that's 1/2, say, yay, similar. And it says a few things up here that we have to do once we know that they are similar. So let's look at these. If so, state how you know and complete the similarity statement. So how I know is all sides are proportional. That's a big word. Proportional means they are all in proportion with each other. All sides are proportional. That's how we know. The similarity statement is triangle something 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 is similar to triangle something something something. We need to give it a name. So triangle, this is where we follow the letters, and I'm going to start with one corner and work my way around. B, C, D. That's how triangles are named, is by picking the corners, the vertices. And then we put a little squiggle, meaning similar to triangle something down here. You'll notice that this color coding is going to come in handy. So if you're not using colors, again, one more pitch to use colors. The side B right here is between the green and the red. So that means side T is going to be the one that matches up with it. In this case, it's going to go in the same order. That's not true of every picture. The second one I picked, C, is between the green and the purple, and that in this case is going to be side S. So I'm going to go T, S, and then the last one's going to have to be R. So triangle BCD is similar to triangle TSR. They went in the same order on top and bottom this time. They don't always, so just be aware that you do want to look for which side matches with which. Looking down at the bottom of the page, I see some that have angles written in and some that have these little marks written in. I'm going to do one of these. It's the same as the angle type problems. What we are going to do is match up which sides belong with which other sides. So there's my longest side. That matches up with that one, and this is my shorter side that matches up with this one. This other side here is unmarked, so we don't have anything that we can do with that. Again, I'm going to choose to go top over bottom for consistency. I have 8 over 20, and that should be equal to, if this is a similar triangle, 5 over 10. When I find these fractions, 8 over 20, that reduces to 4 over 10 or 2 over 5. Or if you just want to do decimal, it's 0.4. 5 over 10 is 1/2. It does a decimal, 0.5. They're different, so you would just put not similar and be done. Now, if both of these were proportional, having two pieces of information is actually not enough in general. However, if you have two sides and the angle between them, those little marks, those two little marks right there, say that angle U and angle R, the one from this triangle and the one from this triangle, are the same angle. They have the same measure. In the same way that if you look over here, this angle is 29 degrees, though it's poorly marked. This angle is 29 degrees. Because they are the same angle in the same place on both triangles, that means that two sides is enough to prove that you have something similar. Same idea applies here. This angle and this angle are the same. So as long as these sides end up being proportional with each other, then you would be good to go. Good luck.